All right. Welcome to, I believe this is the third or fourth IBC call.
I think it's the third.
It's the third. All right. Awesome. Well, let's get started with a quick round of intros. Mark, do you want to get us kicked off here?
Sure. I've been working on smart contracts for a long time before blockchain, especially language, object capability language-based smart contracting. Initially I was puzzled by blockchain, but now we have a very smooth vision about how the old architecture fits in with the new blockchain-based world. And that's what we're doing.
Awesome. Thank you, Mark. Vasily, do you want to go next?
Yeah, I'm Vasily from the gaming. We are working on many things gaming. Some of them are related to Cosmos. Basically, we're doing a Tendermint hack for games with the built-in random beacon. And we right now, concerning IBC, we are working on IBC specs. Done some work the past 2 weeks.
Awesome. Vasily, we're going.
Sorry, lost you. Sorry, I lost you.
Your audio cut out.
I said Vasily. Oh, sorry. I said Vasily. We're glad to have you joining us. Thank you for coming. Rick, would you like to go next?
Yeah, my name's Rick Dudley. I do a lot of work just advising different projects in the blockchain space. Yeah.
Hi, Rick. Well, thank you for coming to the IBC call this morning.
Hi, Jay.
Dean.
Hi, I'm Dean Tribble, and I too have been working in smart contracts since the very late 80s, and and I am CEO of Agoric, and working on large-scale distributed application of this stuff in blockchain.
Cool. Nice to meet you, Dean.
Brian?
Hey, I'm Brian Warner. I've been doing object capabilities, trying to bring it to Python for a long time after having learned it from Mark and Dean. Now I'm with Agoric and trying to bring safer programming languages to the blockchain space and trying to treat blockchain as specialized machines that have higher credibility than the usual machines we run on, but otherwise it's the same uniform programming and messaging model.
Yeah, I like that. Ishmael.
Hey, I'm Ismail Coffee. I work at Tendermint Core, and I aim to contribute as much as I can to IBC by reviewing and implementing parts of the IBC spec as soon as it's there, mainly in Rust and some in Go as well.
Awesome.
Cool.
June.
Hi, I'm working in Tendermint. I'm mostly participating on the specification process on IPS repos, and are going to work on the implementation of the Cosmos SDK, which is written in Golang.
Awesome. Thank you, June. Chris?
Hey, I'm Chris. I'm leading the specification process from the Tendermint side, working on everything IBC, although mostly at the protocol layer. Hopefully application layer specifications will diversify out in a diaspora independent of what Tendermint Cosmos does.
Awesome. Bucky?
Hey, I'm Ethan, co-founder of the projects and generally working on Tendermint and IBC.
Jay?
Hi, I'm Jay Kwan, co-founder of Tendermint Cosmos project, and yeah, here to help.
Awesome. Well, I'm Jack Zamplin. I'm the product manager on the SDK, and I'm helping coordinate these community calls. So, Chris, do you want to go ahead and get us kicked off with this week's agenda?
Yes. So I think the document I shared should be editable by anyone with a link. So feel free to, including people outside of Tendermint, which required some extra Google finagling. Let me know if you cannot edit it. But feel free to add any questions or things you want to discuss. And in the future, we'll try to share this agenda prior to meetings so you have more time. Sorry about that. The first thing I want to cover this week is some work we've been doing on the Tendermint Cosmos side to write up a much better architectural overview of IBC and a list of terms which are used in individual specs. From some feedback from people who started reviewing the specs who didn't have a lot of prior exposure to IBC and found it understandably confusing when there were circular references and they didn't have some of the context they needed. So first version of that has already been merged to the repository and is available at the first link there, docs/IBC. And a second version of that is currently in a pull request number 70, which I also linked. I would encourage you, if you want to use IBC, if you are planning on reviewing some of the individual ICS specifications, which go into exact protocol detail, or if you're considering using IBC and watching this call later, to read this architectural overview. It's probably at this point the most condensed, concise explanation of what IBC does without going into exactly how it's implemented. And we'd really appreciate review from especially people who don't have deep exposure to IBC, and see whether it makes sense from the intent is that you could start at this repository and read through these sets of, at this point it's 3 documents, one that outlines the architecture, one that discusses sort of design principles, and one that lists specific terms which are used in specs. The idea is that if you start through, you should be able to read those documents in order, and when you're done, understand more or less what IBC is and be able to review more specific protocol specs. Does that make sense?
Yeah, we can do that.
Cool. Would it be helpful if I run through that quickly on this call, or do you just want to read it independently?
I think it's better if I just read it. It's like more pure experiment.
Okay, that is quite true. Let's do that then. So this week, yesterday and earlier today, June and I have been continuing to discuss what kind of differentiation we want between connections, which are stateful agreed upon identifiers in 2 chains, and light clients. After some suggestions by Jay at last week's core call on whether or not we needed to have a bidirectional connection handshake or combine 2 unidirectional connections. And I think we've come to the conclusion that we want to have a specific kind of bidirectional handshake, but that we can share the light clients so that there could exist a unidirectional connection between 2 chains and also a bidirectional connection without any duplicate header relay required. So this issue 72, which is linked, has a bunch of pictures of whiteboards upon which we diagrammed this out. And it's in the process of being written up, although it's not yet.
Just one quick thing. I thought more about it, and I'm fairly convinced now that starting with the bidirectional is the right approach. Because it's hard to explain why, but I think you guys kind of explained it from the beginning. And like you want to, before you send tokens, say, to one chain, you want to know that that you can receive anything back. So it's also definitely nice to have that confirmation. And I would say if trying to create trying to create it in terms of composed unidirectional channels is going to make it, take longer to implement. And I feel like we should definitely just go ahead with bidirectional only. And maybe we can close this line of investigation if that will speed things up.
Yeah, I agree. I mean, we did try to compose a way to merge 2 unidirectional connections, and that would be possible too. But it seemed kind of weird because if there were applications on one chain using a unidirectional connection, they wouldn't necessarily want it to be merged. So it didn't make a lot of sense when you considered the whole life cycle. What we thought made more sense is to have specific light clients, and rather than initializing the light clients in the bidirectional connection handshake, have them be initialized separately, and then have the bidirectional connection handshake use light clients that were already there and assert that the chains that were talking to each other were expecting each other, which gives you the same security properties.
And remind me, the use case for the unidirectional channel is really for a broadcast. It's really for a one-to-many.
Yeah.
Go ahead.
That sounds like a great use case. Yeah. But yeah, I mean, originally I was thinking maybe it would actually be simpler to do compose token transfers through through two unidirectional chains, but I no longer think that's true.
I mean, go ahead.
Go ahead. I was going to say, there's a related issue about bidirectional channels, and I'm curious whether you talked through it, about if A and B are going to talk, and A reaches out to B to start a connection, a bidirectional connection, simultaneously with B reaching out to A to start a bidirectional connection. Now you have what we call the crossing hellos, where the first question is, does the system assume that there is a single connection between A and B? And if so, how do you collapse those two connections into one? And you probably want to collapse those two connections into one for sort of, semantic performance anyway, even if it's not security critical. But the crossing hellos is it shows up as an interesting problem in server-to-server connections. Question is, does it show up here is it an issue here as well?
I think it is possible, but substantially less likely or concerning, because there's no, maybe a connection occupies some amount of space in the state machine, but you pay for that when you try to open it. And if you don't use it, if two connections somehow get created at the same time, which you can't prevent because the roots of trust could vary, you just choose to use one, like the bank module will choose which connection it wants to use to the bank module. And the other connection, if it remains unused after some amount of time, could be, I guess, automatically garbage collected.
Yeah. And I guess the kind of scenario, and there's probably some equivalent, is if over connection 1, A hands something to B, and over connection 2, B hands it back to A. Can A recognize it as something that was on A, and does it have, what security properties does it have? So that's a very abstract concern, but just thought I would raise it to make sure you had it on your radar. Okay.
I think we want to allow multiple connections between two chains, and I guess this goes into the last thing I added in the doc. I had a question about the IBC architecture doc. I just scanned through it and I saw multiplexing. And I feel like to get for IBC 1.0, the thing that we will release first, I don't think we should consider multiplexing within a single connection, but rather just have people create multiple connections. I feel like we'll be able to get things done sooner if we do that. But we can come back to it later. So in the case of crossing hellos, I suppose that would just result in two separate connections.
Right.
So just a way of caution, it might very well be that in the in the new protocol stack that we're all building here, it might not be a problem. But the note of caution is that in the old, very connection-oriented E-architecture of CAPTP on VATTP, much more connection-oriented than what we're all doing now. It was the case that CAPTP relied on the uniqueness of connection between a pair of VATs. And if two connections had been allowed, the CAPTP layer's stateful assumptions would have gotten screwed up. In particular, there was associating a set of import-export tables with each side of a connection, but assuming that it had one bilateral pair of tables for speaking to a particular counterparty. So, and also ordering assumptions. It was assuming that a connection was a cheap way to get FIFO orders. So the other ordering assumptions were built on that. And if you had two connections going on at the same time, then they wouldn't be ordered with respect to each other. Once again, none of this might be a problem now, but I want to make sure to put it on the table as something to examine critically.
And Mark, was there a sense of like multiplexing in that single connection between two VATs, or was there only just one ordered stream?
So so it depends what level of abstraction we're talking about. At the CAPTP level is multiplexing many capabilities over one VATTP connection. And in the so there's that level of very direct multiplexing with the tables that I'm referring to on both ends. being the bookkeeping for doing the multiplexing and demultiplexing in a coordinated manner. With regard to other data streams that are not to be fully, that are supposed to be able to proceed at their own rate, independent of the symbolic capability traffic. Going all the way back to electric communities, we did have separate data channels for carrying data in a way that could proceed in its own rate separately from the symbolic traffic. But all the symbolic traffic, all the sort of the capability messages, those were all on one logical data channel, so that we had the cheap FIFO ordering as well as the coordinated state.
Okay, thanks.
So we need multiplexing for two different reasons that I'm aware of. One is to enable parallel data streams for things that don't need to be sequenced. But the other is to enable sub-permissioning for modules within blockchains. So if there is a bank module on chain 1 and a bank module on chain 2, we want the bank module on chain 2 to be able to only accept packets from the bank module on chain 1, not like the staking module on chain 1. We want to include this notion. Maybe it's easiest to understand this with an analogy to smart contracts. So I think we want it to be possible for you to deploy a smart contract on chain A, deploy a smart contract on chain B, have them each bind to a channel, then associate those two channels with each other such that people can keep on deploying smart contracts to chain A and B and using new channels, whatever. But once the channel pair is associated with each other, I guess just by providing the number of the counterparty channel to the opposite smart contract, those smart contracts know that only they two will be talking to each other. And here the smart contracts and modules within the Cosmos SDK are pretty analogous.
Yeah, but like that stuff that can be it can be layered on top. So like TCP/IP doesn't have multiplexing, and you can implement multiplexing on top. So in order to, I would argue that the MVP would not include multiplexing, and we can get application developers, SDK developers to figure out multiplexing later.
It sounds like it might be a shift in the programming model at that point. Like, how is it that one module grants permission to a different module? How does it name the other module that it's willing to accept connections from? And it sounds like that might change from pre-multiplexing to post-multiplexing in a way that application programmers have to
There
modify
could
their
be
code.
reserved ports. Like, I mean, ports, we're calling them ports, and they are sort of like ports in TCP are the names of channels. And there could be a port called bank, and it would be safe if IBC handlers agreed to treat that as connecting to a bank module with certain semantics to like reserve that as a port that no other modular contract could bind to.
There might be an intermediate position where you have the API for multiplexing, but you're only ever allowed to use port equals 0 at this stage, and then later it accepts more.
Well, so this raises the question of the distinction between a connection and a channel, right? And I thought the point of the channel was that you could have multiple streams where each has their own ordering, but they're not totally ordered across them. And maybe we should actually question that, because like, what is actually the use case where you need these independent streams to have order, to be partially ordered across them and totally ordered within them, when they're all happening on a single blockchain that is totally ordered anyway. So so I guess kind of questioning the value of that channel abstraction at this point versus something that's just purely about the multiplexing.
I think the answer there is that it costs a fee in order to acknowledge and recognize a packet in a channel on the other end. And so, and on the sending end too. So even though it's totally ordered on the sender, on the receiver, due to fee mechanics, you might not want to acknowledge one packet that was sent earlier than the other in two different channels. But I would still argue that like this can still be implemented as two connections, and so I don't see why we want to do multiplexing at this time.
Yeah, I think it can be implemented with two connections. it will require more handshakes than are strictly necessary. And there are some reasons to think that it would make sense to separate the identifier, because a connection, if there's like a single bidirectional connection between two chains, will have some identifier on each chain. And it's convenient if all the modules or contracts which are sending packets to that chain can use the same identifier as opposed to using different channels. But I agree that it's not strictly necessary.
It does seem like also tied in with the bidirectional versus pairs of unidirectional, you might want to have one layer that says, how do you talk to a machine? Another layer above it that's talking about individual channels or something. And you amortize all of the proof checking and state about the other chain's state in that lower level piece.
Yeah, the concern with throughput in multiplexing, I think, is more about receipts. And maybe we can change some of the receipt logic so this just isn't necessary, but at least one version of the packet relay algorithm required round-trip receipts before sending another packet. So it required an outgoing packet committed on chain A at some index, the packet accepted on chain B or rejected, and a receipt committed back to chain A. That will slow things down compared to multiple channels because you're limiting the single packet round. You can't commit another packet on, it's not like you can't queue indefinite packets. You have to actually wait for the receipt.
That'd be unfortunate.
I actually don't think that's necessary, Jay, but we haven't gotten to that point in the protocol specs. Do you recall why that was and whether you think it's necessary?
Sorry, I don't understand the question or the concern.
So one version of the receipt handling had it such that you would not send a packet on chain A for index I plus 1 until you had sent the packet at index I, confirmed the packet at index I on the other chain, and confirmed the receipt for the other packet at index I.
No. I definitely don't think we should do that. The way I see it, the sending chain should have an egress queue or outbox queue of packets that are sequentially numbered for each connection, starting from 0, I suppose. And then on the receiving end, the receiver should, at least for the initial IBC implementation, I think it should receive packets in order, and so sequentially. And then acknowledgement going the other way should just be the latest contiguous sequence number received, and so you can bulk acknowledge it at any time.
Yeah, we may require additional data like success or failure associated with acknowledgements.
Success or fail. So so chain A, packets, egress queue. Chain B, you acknowledge or you submit those packets in order, and then some acknowledgement packet going backwards. And you're saying chain B then would want to know that something was acknowledged, that the acknowledgement was received on chain A?
No, I'm saying that chain A might want to know something about what happened when the packet was executed on chain B, like whether a bank module succeeded in minting coins, say.
In TCP, that's done with a separate message, right? There's an ICMP message that says your packet got thrown away because of a filter, or the port wasn't listening, or there's a TCP level acknowledgement for that. But all the application level stuff comes up at a higher level because that packet might have just been put into another queue. No actual processing was done on it yet. And now it's no longer in the responsibility of the TCP layer anymore, but that doesn't mean the application layer can stop worrying about it or knows what happened with it yet.
Mm-hmm. And I agree with that separation. But if it's like more efficient to do it this way.
Yeah, I think that there's a logical separation, and then there's a implementation opportunity to collapse costs, which is whenever you're sending a packet in, whenever you're sending application level message in one direction, you're doing it in a packet going in that direction, and that packet can easily include the latest ACK, but logically, the ACK is still a separate message that's just bundled in to the packet containing the application message.
Oh, that's fine. That's always fine. We can always like combine things with range proofs more efficiently.
Yeah, but I think
talking about what data is being proved back to chain A, and that it may include more than a sequence number.
Yeah, I don't think we want to. I don't think we want to get to the point where we could like pass information about like whether that packet errored or was successfully received. But I feel like it would be much simpler to get started to just say that if there is an error, that it's up to the receiver to say close the connection and just error out, you know, and assume that everything is working fine as long as the connection stays open.
I mean, one criteria you might use is what is the sender supposed to do in response to that ACK or that failure or that error message. And, you know, if it's, I haven't seen the message yet, therefore I need to leave it in the queue, or I have seen the ACK, therefore I can delete it from my outbox.
Right.
The other status, it's going to be something up to the application. And then should the lower level queue management, outbox management, remove it from the queue or not? Like, you know, don't do a test that doesn't affect your behavior.
The question is whether the application does something else. Like in a very tangible example, we're sending coins and the application on chain A escrows the coins when it commits an outgoing packet. And if chain B, you know, receives the packet but fails to find the address that the coins were supposed to go to, it says I failed, and chain A is supposed to de-escrow the coins back to the original owner.
So the way I think of that separation is that at the lower level, the acts and things are just about trying to get the message from here to there. So the act says, I got it, you don't have to keep resending it.
Yeah.
And then the issues about coins and escrow and whether something happened, that's much more application level.
Yeah.
And the response there is as far as the lower level is concerned, the response is just a message going back in the other direction.
Yeah. Yeah. So like if I send coins to an address that doesn't exist and the sender and the receiver doesn't acknowledge it, I think it's up to the application layer on the sender side or receiver side to send some packet that like returns those funds or something. So I don't think IBC should be concerned with that.
Quick meta point, I cannot edit the document. I was trying to add a note.
Let me try.
I pasted into chat, but I was unable to edit the document, so other people probably can't either.
Mine says view only as well.
Try reloading the page.
Oh, yeah, mine says view only. Didn't notice that.
Now I have the power. Okay, thank you.
Great.
One thing that kind of ties into that Dean had reminded me of earlier was pipelining. So, you know, being able to send a message, making sure that you don't have to wait for an acknowledgement before you can send the next one down to avoid the latency cost of that. For the connection setup, there's a bit of a tension there. I think Jay mentioned before of, you know, you don't necessarily want to send coins, to lock up coins on one chain in sending them to the other one until you're convinced that there's somebody there to receive it. And if that fails, then there's a timeout and you've lost that liquidity, lost access to those coins for some period of time until you get it back. That's a little bit at odds with the hope of being able to send a message to send them some coins, send another message following it to say what to do with those coins, and not wait for a stall between those. But it may be that the first time you open up a connection to a new chain or open up a new one of these connections between different modules, you're willing to take that hit because it increases the safety of that. But then later we should make sure that you don't have to wait for one message to get delivered before you can send another one that references its result.
Well, on the app side, so see if this, okay, the way I see this could happen is on the same connection, and again, I'm not considering multiplexing. I'm considering application level multiplexing. But there would be some packet that says here send these coins to user foo on chain B, and then the next subsequent packet may be another kind of packet that says do this with this coin, and then on the receiving end on the application side on chain B it can just realize that the coin that is being referenced was not successfully received, and therefore just ignore the second packet's request.
The equivalent in our world is the first message you send in creates a promise for the result of it. The second message is targeted at that promise. So like
right.
it knows the number or the index or whatever of what's being generated ahead of time, and the second one targets that in the same way the first one targeted the bank or the wherever the coins are going. Which means the first promise rejects, right? It's like something failed about transferring those coins. Therefore, that promise is resolved to point to an error object. The second one that comes in being delivered to an error object causes another error object of its own.
Right. Yeah.
So
but that would all be implemented on the application
at the
layer.
application level, right? Right. So just, from the messaging layer, it'd be unfortunate if one message getting sent in had to wait for the previous one to be acknowledged, because then that forces a full round trip stall between any two pairs of messages.
Yeah.
And the promise pipelining stuff we've got
actually
is like this huge win.
Yeah. I have something I want to bring up about ICS 3 and 2 and modifications to that, but we can get to that at a later point.
Am I confused because the docs I was looking at?
Which doc are you looking at?
Word at the beginning. Sorry.
Dean, you keep muting yourself.
So I do, sorry. It's when I alt-tab away from the window. So I was looking at the IBC architecture documents on master docs IBC, so the very first link in the document.
Yeah.
And so like terminology, I was just looking, it doesn't have port. So there were just a lot of things that are not there yet. And so the question is, what status is this in? Similarly, it felt I have to go back to the older specification to wrap my head around what's going on so far. How's that?
Well, that is not the goal. Have you checked out the PR number 70?
Let's see. I was going through PRs.
You'll want to do view file of the target of the PR to see the rendered version with its changes.
The target files changed. Did you mean?
In the pull request, in the diffs,
yes.
Find the diff for document 1, say view file at that button on the right.
Okay. So I'm looking at the wrong thing. All right, good.
Yes, port is not defined in that document, and it should be. But most
yes, there is much more. I am now looking at the right thing. Thank you.
Sure thing. Okay, broadly, I agree with both of those, Jay. I think we can mostly. I'm not sure if it will save us that much time to omit multiplexing because it's just an additional field in the key, and it's useful to think about the multi-module semantics. But if we think it will save us time, we can omit it.
Okay, well, if it's simple to add it, then we can start without it, and then we can consider it in the future.
I just want to make sure we consider the case of like more complex things than token transfers, where there are multiple modules on each chain, and we want there to be some like bipartite graph between them that is not just a connection.
My issue with thinking about multiplexing at this stage is that I don't even think that multi-module is the right way to think about it. Like I think of modules as generic, abstract software modules that provide some functionality, but I'm not so sure that it is, like intermodule per se. Like I'm not sure that's the right way to think about it. Because an application could import a lot of modules, but have implement a single callback system on an IBC connection and do arbitrary things that ties in, that dispatches to modules depending on the situation. So I think the flexibility, not having an opinion about how multiplexing works would make it more flexible so that we can do more without adding unnecessary complexity in the beginning.
Yeah, but I think we want I don't think we want to be opinionated, but I think we want enough of a shared semantics that two blockchains with mutually distrusted module sets can communicate over a connection with modules that trust each other. So if I trust the bank module on chain A and the bank module on chain B, but maybe not other parts of the state machine, it would be nice if we can, makes much more sense in the context of trusting a smart contract on one chain and a smart contract on another chain, but not some other smart contracts in both chains. If the IBC handlers can ensure that packets are routed just between those contracts, then that restricts the set of what I need to think about a lot.
Yeah, but I mean, so that's just going back to, you could just create multiple connections. So why not just do that? And then I think initially, I think multiple connections, there will be duplicate work, right? Because the easiest way to implement it would require there to be multiple root of trusts or commits or validator sets being tracked for the same chain.
No, we can get rid of that. That's not hard.
It seems wrong to have more than one copy of the roots of trust for any given target chain.
Yeah. I think it would be inefficient. I don't see why it would be wrong per se.
It suggests that something's not being handled at some level that maybe it could be, because you are building an operating system here, right? You're not asking user space to do TCP.
So I have a question. This feels very abstract, where some of the answers will be addressed by, should be clarified by concrete examples. Obviously in the background, we're going, okay, how does this map into, VATs or objects or OCAPs or what have you? But there are other concrete examples that could drive, what is the limit of doing it where there's no multiplexing at all? What's an example that shows off multiplexing? Because if we don't have that example, it would be easy to do multiplexing that wouldn't actually solve the problem we needed to solve anyway. And so, for example, I had mentioned pipelining, or rather Brian brought it up earlier. If you did multiplexing, but A connects to B, B decides what the port number or ID is for the next multiplex connection, suddenly you can't do pipeline setup of multiplexing channels. Depending on the use case, that might be important, and that's a very different structure for setting up the multiplexing. And so is there some more concrete set that would drive this? And if the answer is, yeah, it's better to let multiple approaches to multiplexing work initially until we see what the answer is, then that would be an argument for not specifying that yet until we're a little farther along.
Multiple approaches make it really hard to reason about security though. So, yeah.
I mean, now I'm thinking about.
I agree that's true abstractly. The question is concretely, I expect we need multiplexing, but I'm suspending disbelief until I know exactly, until I can map it to a real scenario.
So, I mean, now I'm thinking about the early Unix internet low-numbered ports representing authority on the sending system, right? And doing access control based upon a number that the attacker had full control over.
Yeah, which just turned to be a disaster. I mean, it's just totally terrible, right? Bad multiplexing.
Let's just take Dean's point and sort of look at it from the other side, which is we have a concrete scenario that's that can be one of many for use of the underlying technology, but it is a concrete scenario that we've thought a lot about, and that clearly you guys are it's very much aligned with your goals, which is that the real multiplexing and demultiplexing that we're trying to support at the application level is per object, per capability, and that really that's sort of the ultimate target of the multiplexing and demultiplexing logic from our point of view at any lower level is to ultimately achieve the multiplexing of capabilities and messages to individual objects. So we can just take that as a concrete scenario that that places a set of requirements and see how that plays out. And then as we have other concrete scenarios, we can examine those as well. But that does give us the first concrete one. And then like we've been talking among ourselves about the IBC module concept. What is the best mapping of that into the concepts that we have, the various levels of abstraction, on top of which we eventually get to individual objects and capabilities and messages.
That sounds useful. I want to quickly note that IBC is definitely different than TCP multiplexing in our goals. Although we probably don't want to assume that certain port numbers are always, communicating authority or something, we can assume that the processes involved are much, much, much more reliable. And a very key use case is where the user trusts different modules running on different chains connected over IBC, but maybe not some other modules running on those chains and wants to talk to them, or maybe just doesn't know about the other modules. So like if the bank module gets port bank on 2 chains and can talk to each other, once it's been allocated port bank, if someone assumes that the state machines of both chains are behaving in their expected way, no one else can claim port bank. So in that sense, reserved ports or whatever can be the way we want to implement things, I think.
Well, I like the idea of rather than using port numbers, maybe port names, because there's a lot of overhead already in all of this. I don't think it's too expensive to use a string. And then maybe every packet can have a, like you said, maybe the way to implement this is pretty simple. You just have a field in a packet that is some identifier or name space, and then we can restrict that initially. And then, yeah, 2 different blockchains can have capabilities communication, for example. Yeah, I can see that. The other point is I can see a need for multiple connections where like if we think about these as processes, then maybe in the future between chain A and chain B, there might be 2 connections, and then one process might migrate to another chain, in which case that connection would just move on to another chain. So I feel like it'll lend us to doing process migrations, but probably not very important right now to consider. We don't have much time left, 15 minutes, and I do want to get into the ICS 3 and 2 and something I noticed about that.
Sure thing.
Okay, thank you. And specifically, it's right now, if you read ICS 3, there's a comment. Let me find that comment real quick. Sorry, it's about storing multiple headers. So when, say, chain B, you commit you submit the commit of chain A onto chain B. I think the way things are written now in ICS 3, there's only the latest header that is stored. And this will be problematic because other applications or relayers that, it would be possible for one relayer, say, to update the latest header of chain A onto chain B in such a way that another transaction that is being committed that references a previous header no longer works. So I believe we do need to keep a kind of like a FIFO list of headers to represent. Yeah, so on chain B, there should be more than one header, some FIFO list of headers that are being tracked such that Merkle proofs to packets can reference any of those headers that have been verified. And I think there's additional questions that arise here, such as like, is it possible to submit, is it possible to submit headers that like, I out of order, right? So is it possible to submit a block, a header for block 10, and then 20, and then back to 15? You know, and I think maybe the answer is no, but I just wanted to raise that need to keep multiple headers.
But if you accept transactions from a previous header, how do you know that their state is still valid?
Because the Merkle proofs would be proving to like a packet number, and so regardless of the header, you would ultimately be proving the same kind of thing, and you can still prove a submit sequential packets in there. And so so in terms of at least submitting packets from chain A to chain B, it wouldn't matter because you're only accepting sequential packets anyways.
So I agree with that. ICS3 is not intended to contradict anything you just said, so maybe it's unclear. It's true that we're calling the thing that's being stored a root of trust, but that could include multiple headers. We're just sort of trying to abstract over that property. But we could discuss in more detail the concern about relayers submitting new headers and why it would be wise to store multiple.
Right. So
you don't need to store the whole old header, right? You just need to store the accumulator root, the state tree.
So no, I don't understand. Honestly, I'm like, I think these terms are a bit confusing. Root of trust or accumulator root maybe is better, but root of trust I think is confusing to me. I would almost prefer to rely on the basic primitives like commit, header, and maybe not introduce new terms. But yeah, like a root of trust, and like yeah, you know, okay, so let's not worry too much about the names right now, but yeah, certainly the definition would have to change. I'm totally fine with there being a single structure that stores multiple headers in a FIFO fashion. Yeah.
Okay, we can think about the best naming. I mean, it's not a commit either, right? Or even a list of commits, because you don't need to store the old signatures. You just need to store the old state roots.
Right. It's not a commit. It's
a list of, it's the last commit plus some old state roots.
It's the last commit. Do we even need to store the signatures after you've verified them? You just need to know the validator set.
Yeah, I guess you don't.
Yeah.
Although if in the future we do want to support bisection, you need to store the signatures or at least the power distribution.
Yeah, I don't think we should do bisection though.
Okay, I agree. So we don't need to worry about that yet. But we could at least try to make it theoretically possible in our data structure definitions.
Since there's a lull, I'll just insert a general point about terminology, is that although I occasionally find myself using the word trust, despite my better judgment, what I've generally found is that it's best to avoid the term trust because it raises so many intuitions that are in the wrong direction. Trust often seems like a good thing. So instead of whenever we think to say A trusts B, to instead say A chooses to be vulnerable to B. It kind of gets the right emphasis.
Or assume.
Or
I'm also,
relies on B is our other terminology.
Yeah, relies on is good.
I'm also a little hung up on the word root as well. It feels like root should be like the Genesis state or something. Yeah. But I think it's fine as a placeholder for now. Something that stores headers, latest validator set.
We could just call it the verifier state.
Not as sketchy.
How about consensus state? There's connection state. And there's
I thought consensus state would be confusing because it's a struct in Tendermint.
Yeah.
I'm okay with consensus state.
Okay.
In Kikos, the equivalent thing is referred to as holes, because you have the set of holes that you're allowed to have in your system, and now I can verify that something has no additional holes. And the holes are the ones that you're relying on. They better be right.
We've got a few more minutes. Maybe we'll talk about the NFT work we've been doing.
Oh yeah, that would be great. Sorry for getting.
That would be awesome. Yeah. I would like to hear.
Okay, there is this issue, number 30. Over these 2 weeks, we basically had a look at everything that had been done on the topic in Ethereum and in EOS. Most of NFT use cases are perfectly described by the ERC 721. So basically an immutable token that has some metadata and can be transferred, and that's it. But Ethereum has a real treasure trove of variations on that. There is a lot of logic that developers want to put on NFT in addition to what basic NFT represents, like semi-fungible tokens engines doing, or ownership stake in a single NFT token, or security NFT token, or token that are fungible but in a really weird way, like they decrease their value or something. And there is a lot of those. So I think we should for starters focus on the basic functions, like a token that has some metadata and can be transferred from one account to another, and that's it. There is no weird logic. There is.
I'm sorry. There's no what logic?
Weird.
No packaged logic, like
no strange logic that's hard to implement across multiple chains. The second question that we must address is how to store metadata. There is a lot of fights over how metadata must be stored, even in Ethereum community. So people constantly write that ERC 721 is fine, but metadata format is just not working for me, proposed, and so on. And they propose their own substandards for different kind of tokens. And EOS is doing it from the start. They are defining a digital goods standard that has a lot of different metadata formats from scratch.
Can you post a link to that?
Everything is already in the issue, in the second comment.
Thanks.
You can see. The thing is, we might want to borrow EOS approach and has a registry of different metadata standards that are compatible across different Cosmos chains. I don't know if that's a right way to do it, because it adds some centralization to the system. We are making another standard that all Cosmos chains better follow. That's debatable. Or we may leave it up to the chains, to the individual Cosmos participants to agree on metadata format. That's something I would support. Another thing, we are a basic NFT packet data structure would be easy to design, except the part where we must decide if we want to designate a scheme for the metadata inside the packet, or we want to just store an URL in there and let the application figure it out themselves. it's all there in the comments. So if you have an opinion, we can discuss it right there in the issue. We don't have much time left, so.
Yeah. Do you think there will likely be some metadata that's just for UIs and so can be exposed by a URL, but also some metadata that applications want to take action on, like not quite like non-fungible token with properties or something?
There is a use case that Andrew that was with us on the last call. He thinks that a very valuable case for having a metadata standard specified in the NFT packet is for a chain, for a smart contract to figure out if it will accept this exact NFT or not. So like a marketplace for gaming goods that won't accept digital art, for example, I don't know, or won't accept something that some adult content, for example, that's things like that. It might be prudent to have that designation right in the packet.
Well, okay, so I feel like we should, yeah. So I'm on the very bottom of the document. It looks like Chris agrees. If we create a mock interface to IBC, then I feel like we'll be splitting the problem into two parts, and we'll be able to tackle it from different angles, and we'll be able to start specifying like how NFT might work, how multiplexing would work, and actually very soon developers can also start implementing IBC compatibility even before IBC is done implemented. So I feel like it's maybe that's a very good thing to start focusing on as soon as possible.
Yeah, I agree.
Coupling these different parts of the stack seems like a great.
Yeah.
And it will clarify some other decisions, like for multiplexing. So I agree.
Yeah.
Cool.
All right. Thank you.
Yeah. One person who would be great to discuss the NFT token spec with is Billy on our team, who's not on this call, but knows more about NFTs and the NFT ecosystem than I do. I think it would be good to try and have like some very basic token NFT packet standard with no metadata, with one metadata link, and then a bunch of optional fields or something. The more we can allow applications to customize it, the better.
One more thing I wanted to discuss is I've had that idea that IBC basically allows us to, I think that it allows us to make state channels between different blockchains. We can design chains in a way that you don't need to instantiate a connection and follow the packet if everything is well, basically, if we can make a state channel between two different blockchains, if everything is collateralized, and we can always settle it between chains using IBC.
Yeah, that's probably true. I mean, IBC is not doing much in that model. It's just kind of like an interface for.
That's a settlement layer, yeah.
Yeah.
Right. I do have a comment on your earlier NFT thing, if I may go back briefly. You know, and this is a little bit of bias or disclosing bias or whatever. From my perspective, in general, NFT and even, you know, FT, you know, they are all crappy ways to recover some of what you want out of OCAPs. And that's not quite true. It's not entirely fair comparison. But instead of having an NFT that represents a concert ticket, I'd rather have a concert ticket object that I can ask, hey, what time's the concert? And, and it's got messages to hook me up with parking and all that sort of thing, but it is an ownable and tradable and transferable asset. NFTs are trying to recover the ability to have bearer instruments approximately. And all of the dance around ERC20 and ERC721, for example, are things that, that in other systems have been the goo that the comm system abstracts for me, where, I as a system that's trying to hand a reference to another system, I have to tell my comm table, i.e. the 721 contract, hey, give it to that other system, and the 720, the other system has to talk to that in order to add it to its tables as well. And the juggling ends up looking a lot like what it is that comm systems for object systems do underneath, only they abstract it away so that it can function sort of optimally and differently for different environments, whether it's solo or chain or what have you. And so the nice thing of IBC provides, so I suspect that the NFT support we might want in IBC could very well look like NFT support, but could directly support the transfer of what we think of as object references. The amount of work is very similar. So just as we're looking at NFT, thinking about what would it be if there was an object tied to that particular token that I was able to send messages to in the same context. And the message layer is the layer above IBC. So I'm not proposing that it gets driven into IBC. It's merely a lens through which we'll look at some of what we would want for NFT support.
Well, it's true that most of the strange things people do to ERC 721 is because they try to put some security rules on it or something like that. But it's not necessarily the case. Self-contained NFTs that are digital objects themselves can have pretty much strange logic and complex logic themselves. We don't have much of them in the moment, but the day is young. So I think in a few years we'll see some very complicated economical object in forms of non-fungible tokens, and that will be hard to implement too.
Cool. I think we're at the end of time, but that sounds like a great discussion to continue on the issue. And we'll try to get you by next call, but probably earlier, a fairly concrete module level interface for IBC that you can start thinking about within the context of developing applications on top of it. Anything else, Jay, Jack, Dean?
Nothing else from my side.
Cool. Thanks all. Have a great day. See you in 2 weeks.
Thanks,
Yeah,
everyone.
absolutely. Thank you, everyone, and I'll push this recording up later today.
Excellent. Thank you all.
Awesome.
Bye.